everyone, let's work on some of the review questions together. The first question here is asking us to find the exact value of cosine of 10 pi over 3. When we have an angle and we want to find a trig function related to that angle, the first thing we need to do is to graph this angle. So we're going to start graphing this angle, finding where is this angle located. Well, we know that we always start from here. This is 0, and we go half the way. We're going to have pi here. Since our angle has a denominator of 3, we're going to make this have the same denominator as well. So I can rewrite this as 3 pi over 3. So if I continue going this way and I go back to this point, I am going to have a full circle, which is 2 pi. But if I want to write it in this form with the same denominator, this will be 6 pi over 3. So I'm still here, 6 pi over 3, and I've not reached to 10 pi over 3 yet. So if I go another half circle, I'm going to add basically 3 pi over 3 to 6 pi over 3. So if I make this was half circle, another half circle, another half circle added to that will be 6 pi over 3 plus 3 pi over 3, and it's 9 pi over 3. So 9 pi over 3 is here. And of course, 10 pi over 3 is going to be just a little bit after that. So it's going to be a little bit after that here, maybe. So this is my angle. And we know it starts from here, and we made one full circle, one half circle, and we reached here to 10 pi over 3. So this is 10 pi over 3. We found the angle. The angle is here. Now I'm going to make a right triangle. First, I need to find my reference angle. The reference angle is this little one over here. What is the measure of the reference angle? 10 pi over 3 minus 9 pi over 3. 10 pi over 3 minus 9 pi over 3 is pi over 3, which we know that pi over 3 is 60 degrees. So this angle is 60 degrees. Since this is a right triangle, and we have a 90-degree angle here, so this is 60, this is 90, of course this one is going to be 30. So I know I have a 30, 60, 90 triangle, and in a 30, 60, 90 triangle, ratio of the sides are like this: 1, root 3, and 2. So opposite 30 is 1, opposite 60 is root 3, and opposite 90, which is our hypotenuse, is 2. But I need to consider the negative signs as well, because this horizontal line is on the left side of the x-axis, so it's negative. It's in the negative area of the x values. And this vertical line is below the x-axis. This one is in the negative area of the y value, so this is also negative. Okay, now if I find cosine of this angle over here, basically that's my answer. Cosine of this angle is adjacent over hypotenuse. Adjacent is, so let me write that, adjacent over hypotenuse, and it's equal to -1 over 2. So that's our answer. For the next question, cosine of pi, again, we need to first of all find the angle, graph the angle. Well, we know this is 0, and if we go half of the circle, we're going to reach here, which is pi. So we found the angle. But since this is a quadrantal angle, that means an angle that is on the quarter borders, we cannot draw triangles like this one. We need to use the coordinates. We know that the coordinates of the points on a unit circle, if we consider there is a unit circle here, the coordinates are 1 and 0, 0 and 1, -1 and 0, 0 and -1. And we know that considering these coordinates, the x value is cosine of angle theta, and the y value is sine of theta. Okay, so I'm looking for cosine of pi. That means I need to look for the x value of this point, which is equal to -1. And we're done. Okay. Next, we are trying to find inverse values. Again, we need our coordinate plane. Also, we need to look at the chart that we had before. If you remember, we had all Smarties take calculus. That means here everything, all the three functions are positive. On this one, only sine is positive. Here only tangent is positive, and here only cosine is positive. So based on this chart, I'm going to look at the value that I have here, 1/2. 1/2 is positive. Where is cosine positive? Cosine is positive in the first quadrant because everything is positive in here, and also the fourth one. So I know my angle is going to be either here or here. So I have two answers here. Now I'm going to start with drawing my right triangle. And I know the angle that I will work on is this one. This is my reference angle. Cosine is adjacent over hypotenuse. So I know that adjacent side of this angle is 1 and hypotenuse is 2. Now I can use Pythagorean theorem to find this missing side. This missing side will be 2 squared, which is hypotenuse squared, minus this side. Let's just use Pythagorean theorem first. I'm going to say 2 squared plus 1 squared is plus, 2 squared equal to 1 squared plus this other side. Let's call that a for now, a squared. So a squared is 2 squared minus 1 squared, which is 4 minus 1, it's 3. So a is root 3. So we found that this side is root 3. Okay, let me erase these and make some space. Okay, now I see that I have a ratio of the sides of this triangle and they look familiar for us. We have the same ratios that we see here. So I know that I have a right triangle, which is a special right triangle of 30, 60, 90. Now, how do I put the angles here? The side which is opposite radical 3 is 60, based on this table that we had here. 60 radical 3. So this angle is 60, and this one is 30, and this one is 90, which we don't really care about the others. This was the most important one that we were looking for. So now I can find my first answer. We know that the answer is the angle that starts from the positive side of the x-axis and ends at the terminal side and goes to this direction. And what is the measure of this angle? Of course, it's 60. So that's my first one, 60 degrees. Now the second one, how do I find the second one? Whatever angle that you found here, this one is also going to be the same as this angle. So this is also 60 degrees. Okay? So I don't need to do any of these calculations, anything to find the next one. Whatever you find here, you can write that here as well. Okay, now I just need to find my second angle. We always start from the positive side of x-axis and go to the positive direction and end at this point. So what is the measure of this angle? We know that if we had made a full circle, it would be 360 degrees. We're working with degrees here. 360 degrees, but we need to cut out this part from that to find the rest of it. So minus 60, it's 300 degrees. So the answers are 60 and 300 degrees. For the next problem, sine of theta is equal to -1. We know that sine is opposite over hypotenuse. But it's not possible to draw a triangle with this because if opposite side is, like if this value is -1, that means the denominator is 1, then we match opposite with top and the hypotenuse with the bottom. So that means we have a triangle, a right triangle, that opposite side of the angle is 1 and hypotenuse is also 1. And that's not possible. In a right triangle, always hypotenuse is bigger than the leg. So it's not possible. Then there is no triangle here. If there is no triangle, that means we need to use the coordinates. So we assume that we have a unit circle here. This is 1 and 0. We just write the coordinates again. This is 0 and 1, and 0 and -1. And we know that once again, the y value is sine, cosine value is the x. So if I'm looking for a sine value which is -1, I need to look for a y coordinate which is equal to -1, and that is here. So this angle is what we are looking for. We have only one answer. And what is theta? Your angle starts from here and ends at this point. And this is 3 pi over 2. Or if we are working with degrees, we can write 270 degrees. The next two questions are solved the same way that we did here. So you're just going to make your right triangle, find the ratio of the sides, and then find the angle. So I'm going to leave these two for you. Just keep in mind that you need to do write the angles in radian. And the next question lists the restricted ranges for each of the inverse parent functions. You just need to list the restrictions that we had in 8.3. I'm going to open that for you here. So these are the restrictions. You just need to list these ones here. And next one, we want to find the exact principal value in radians. For this question, when we say principal value, that means you just need to consider the restricted range. So half of the solution is basically the same thing that we did here on top. And just at the end, we need to consider the restricted range and see which angle we want to accept. For example, secant, we know that secant is 1 over cosine. This value is negative. So if secant is negative, that means cosine is also negative. Now, where is cosine negative? Based on this chart, cosine is negative in the second and the fourth, the third quarter. So my angle is going to be here and here. So I can draw my triangle, and I know secant is hypotenuse over adjacent. So this is 2, and this one is negative root 3. We know that hypotenuse is always positive, so the negative goes with this one. And we find the other side, which will be 1. And now I know that the angle is, the one opposite one is 30 degrees or pi over 6. Okay, now I can find my angle, which is the angle that starts from here and ends at this point. So theta 1 is pi minus pi over 6, because half of the circle is pi. We cut out this part from that. Pi minus pi over 6, and it's 5 pi over 6. So this was the first one, but we need to consider the restricted range. We know that the restricted range for secant is the y values which are between 0 and pi. That means we can only accept the ones that are in the first quadrant and the second one, 0 to pi. It's like from here to here. These are the ones that we can accept. But the second angle is in the third quarter, so we cannot accept this one. It's not in the restricted range. So we have only one answer, and that's just 5 pi over 6. So basically, there's nothing like hard about this question. You just need to consider the restricted range that we have listed in the previous question over here, and then see which one you're going to accept and which one you don't. For example, tangent Tangent has a restricted range between negative pi over 2 to pi over 2. That means if I have the coordinate plane negative pi over 2 is here and pi over 2 is here. For tangent, we only accept the angles that are in these two quarters. So this tangent is positive, and we know that tangent is positive in the first and the third one. So my angles should be either here or here, but we don't take this one because it's not in the restricted range. So we only take this one, and I'm going to leave finding this angle for you. For composite functions, you need to consider that we need to do on the inside one first. So we consider this one, we solve this one first, and then we're going to find the answer, replace it here, then find the outside one. So cosine negative 1 of 3 over 5. I know the value is positive, so the angle is going to be either here or here. But we know that the restricted range for cosine is from 0 to pi. From 0 to pi. So I only accept this one, not this one. This one is not in restricted range. Always for composite functions, we need to consider the restricted range. Okay, so here I draw my triangle. Cosine is adjacent over hypotenuse, so it's 3 and 5 here. Now I can use Pythagorean theorem to find the other side. Let's call this one x. So x will be 5 squared. X squared is 5 squared minus 3 squared. 25 minus 9, which is 16, and x will be 4. So this side is 4. Now, what is the answer to this question? It's going to be the angle that we have here, but we don't really need to find that because the question is asking what is the cotangent of this angle. So as long as I have the ratio of the sides, I don't really need to find the angle. I know cotangent of whatever is this value, which is theta, is adjacent over opposite. I have the adjacent, which is adjacent side, which is 3, and the opposite side, which is 4, and that's it. This is my answer. So I didn't need to find the angle. Just have the ratio of the sides, and that's it. For the next question, you need to find the inside one first. Where is 7 pi over 6? So we're going to draw the angle first. This is 0, this is 6 pi over 6, and 7 pi over 6 is here. So you find the angle. This is 7 pi over 6. So the reference angle is pi over 6, and you find the ratio of the sides. I'm going to leave that for you. Once you find the ratio of the sides, then you can find secant, which is adjacent. I'm sorry, which is hypotenuse over adjacent, because secant is reciprocal of cosine. Once you find the answer to the inside one, whatever is the answer, you're going to replace that here and then find secant negative 1 of that value. Whatever is this value, you're going to find that. For solving the second part, you need to have another coordinate plane and solve the question the same way that we did here for the principle. Do not forget about considering the restricted range, and then you can find this. If you think you need more help, you can watch the videos related to this lesson, composition of trig functions. Now, for the next part of the lesson, I'm sorry, for the next question, I want to solve the equation. Our goal is to have the tangent by itself. That means the trig function by itself. So I need to get rid of the 3 and 1. So that's the first step. get the trig function by itself. So I can add 1 to both sides. So this will be 3 tangent squared of x equal to 1. And then we need to divide by 3. Both sides divide by 3. And tangent squared of x equal to 1 over 3. And then tangent of x, you need to get the square root of both sides. Tangent of x is positive and negative 1 over radical 3. Because square root of 1 over 3 is 1 over radical 3. So we have the trig function by itself on one side. Now we need to solve for the x. This was just the first step. Now I need to solve for x. I have two equations. One of them is tangent of x equal to 1 over radical 3. The other one is tangent of x equal to negative 1 over radical 3. And we need to solve for x. For each of these, I'm going to draw a coordinate plane, separate coordinate plane, and try to solve them. Tangent is a positive value, so my angle is going to be here and here. Then I draw my triangle. Tangent is opposite over adjacent, so it's 1 and radical 3. If I use Pythagorean theorem, I'm going to find the other side as 2. Now I know this is 30 degrees. We're working with degrees here. So we're done. We found one of the answers. Theta 1, or let's say x1, is 30 degrees. Then you need to find the other angle. I'm going to leave that for you. Find theta 2. And for this one, again, the same way. This time tangent is negative, so the angle is here and here. You find the ratio of the sides for the right triangle and find your angles. One of them is going to be this one and this one. So you need to find theta 3 and theta 4. Last part is use the general solution. That means whatever you find as the answers, you need to use the general solution. What is general solution? We know that if we have, I'm going to write that here for now. If we have sine and cosine, the general solution is whatever the angle that you find here, you're going to write that and write plus 2 pi n. If you have sine and cosine. If you have tangent, the angle is going to be theta plus, let me write this again. Whatever angle you find here, you're going to add, oh, I'm sorry, I keep making mistakes. You're going to add pi n to that, not 2 pi, just pi n. And what is pi n? Is just 180 times n. So if you want to write in degrees, you're going to write 30 degrees plus 180 n. So the general solution for sine and cosine is this. For tangent is pi n. If you want to write them in degrees, instead of 2 pi, you write 360 n. Instead of pi, you write 180 n. So you need to add 180 n to all these angles. For the next question, again, our goal is to have the trig function by itself on one side. So we have one sine here, another sine here. I'm going to add the sine to both sides. So I get rid of the sine on this side, and on the left side I have 2 sine of x plus radical 2 equal to 0. So now I need to get the sine by itself. So we need to get rid of the 2 and radical 2. So I can subtract 2 from both sides, subtract root 2 from both sides. It will be 2 sine of x equal to negative root 2. Then you divide by 2. These two cancel each other, and sine of x is equal to negative radical 2 over 2. Then you need to find x. You need to solve for x. This is just a normal inverse value that you need to solve. I'm going to leave that for you. Just draw your triangle, your coordinate plane. Sine is negative in this one, and then you do the rest. For the next question, we have tangent squared of x minus tangent of x. We need to have only one tangent on one side. Here we have tangent 2x and tangent x. What comes to my mind at the first side is to finding the factors, like factoring this equation. So I'm going to factor tangent x because tangent squared x and tangent x, they have both tangent in common between them. So I factor tangent x from tangent squared. If you're factoring, that means you're basically dividing. So if I'm sorry, divide by tangent of x. If I divide tangent squared by tangent, this one in the bottom will go with one of them in the top, and I will have only a tangent of x left. Then we have subtraction. Now tangent divided by itself is just 1. So I factored this equation in this way. Now we know that if we have multiple of two, product of two factors equal to 0, that means each of the factors separately are equal to 0. So I can write this as two different equations. One of them is this factor, tangent of x equal to 0. The other one is this factor, tangent of x minus 1 equal to 0. So from here, I'm just going to solve this the same way that we have done before. Solve for x, like the inverse value function. And this one, I am going to move the 1 to the other side. So tangent of x is equal to 1. And then solve for x again, the same way that we have done before. Notice that in this case, tangent of x equal to 0. We know that tangent is opposite over adjacent. So this means opposite side is 0 and adjacent might be 1. And there's no triangle that one side is equal to 0. So there is no triangle here again. That means we need to use the coordinates. So here we have the coordinates, and we know that tangent of an angle of theta is sine over cosine, or y over x. So I need to look for a coordinate that the y value is 0 and x is either 1 or negative 1. So those are this one, y value is 0, and also this one. So the answers are theta 1 is 0, because the angle at this point is 0. And for this one is pi, theta 2 is pi. And then you can look for the other one over here. I'm going to leave this one for you to solve. You're going to find theta 3 and theta 4. For the general solution, you just need to add pi n to whatever value you find here. You need to add pi n to that. Plus pi n plus pi n. Now the last question here, 2 sine squared minus 3 sine plus 1. Let's consider let's just replace sine of x to big X. Okay, so if I replace sine of x with x, this will be 2 times x squared minus 3x plus 1. So we replace sine with x. Why did I do that? Because we have a quadratic equation here. It's like 2x squared minus 3x plus 1, and we know that we can easily solve this by using the big X and factoring. So on top goes a times C. 2 times 1 is 2. The bottom goes the B value, -3. Now we need to find two values that if you multiply them, you get 2, and if you add them, you get -3. So what are those two numbers? They could be 1 and 2, but they both should be negative. So if you multiply them, you get 2. If you add them, you get -3. So I can start factoring this. Since the a value is not 1, I can write this as 2x squared. The middle one is going to be written as -2x minus x. So -3x is -2x, which is this number, and -x, and that's this number, plus 1. And now I group them and factor. From the first group, I can factor 2x. So it will be, I factor 2x squared, it will be x, and factor 2x from 2x, it will be -1. From the second one, I can factor -1 or the negative, and it will be x minus 1. Now I factor x minus 1, and it's 2x minus 1 left. So we factored this polynomial. Now in order to solve it, we just need to set each factor equal to 0. X minus 1 equal to 0 and 2x minus 1 equal to 0. From here, x will be equal to 1, and from here, x will be equal to 1 over 2. But notice that our x was basically sine of x. We had replaced the x with sine of x. So now I'm going to replace them back. Instead of this x, I'm just going to write sine of x equal to 1. For this one, sine of x equal to 1 over 2. Then I can solve this using the same way that we did before here, like this one or this one, any of inverse values. You just need to draw your coordinate plane. Sine is positive, the first and the second. For this one, opposite over hypotenuse is 1 over 1 is not possible, so there is no triangle, so you need to use the coordinates for this one. But for this one, you can draw your triangle. I'm going to leave that for you. For these questions, we need to use the trig identities that I have given to you before. So we need to simplify this and go from this side to this side. Cosecant is 1 over sine of x. You can use the trig identity list that I gave you before and see that cosecant is 1 over sine. And tangent is sine over cosine. Okay, then you can simplify the sine and sine. On top and the bottom is 1 over cosine, and that's equal to secant of x. For this question, it's better if you find the common denominator. The common denominator between these two fractions is sine times cosine. Because they don't have anything in common, you just multiply them to find the common denominator. So this is your common denominator. The left one, this one, needs to be multiplied by cosine to get this common denominator. So you're going to do the same thing to the top as well. So this will be cosine times secant. And this one on the right side needs to be multiplied by sine. So you do the same thing to the top. So it will be sine squared. The common denominator is written here. Now, what is cosine times secant? I'm going to leave that for you to find. I will just mention that secant is 1 over cosine of x. And also, you can use this later. 1 minus sine squared of x equal to cosine squared of x. So you replace these, first replace this here and see what can be canceled out. Then you're going to have 1 minus sine squared. Replace that with cosine squared. And then you can cross one of the cosines on top with the one in the bottom. And then you will have cosine over sine, which is cotangent. I'm going to leave this for you to solve. For this question, it's better if you just replace cosine with cosecant with 1 over sine of x, and this one with 1 over cosine of x. And we know that if we have sine of x over 1 over sine of x, this is division of fraction. So you keep the top, change the division to multiple, and flip the second one, sine of x over 1. So this will be sine times sine, sine squared of x. The same way you can use this one and find this one, and then you can use the Pythagorean identity, sine squared plus cosine squared of x equal to 1. Use that to solve it. For this question, you can do the distribution. Multiple out. 1 times 1 is 1. 1 times negative sine is negative sine of x. Sine times 1 is sine of x. Sine times negative sine is negative sine squared of x. These two cancel each other, and we have 1 minus sine squared. And based on Pythagorean identity, you can check the Pythagorean identity in the list of the trig identities that I have given you before in Google Classroom. And 1 minus sine squared is just cosine squared of x. Here also, you just need to multiply sine times cosecant and sine times negative sine, sine of x times cosecant of x. Then we have sine of x times sine of x. I will leave the rest for you. Find the identity for cosecant of x. And then this is sine squared. So once you find that, 1 over cosecant of x equal to sine of x. And you can also use the Pythagorean identity, 1 minus sine squared of x equal to cosine squared of x. Use them to prove the right side. I hope this was helpful for you. You can still ask questions from me if you need any help. Good luck with your test.